Every time you open an app, stream a video, or send a message, something far away has to work perfectly. The internet isn't floating in the air. It lives inside real buildings filled with machines that run non-stop. These places don't look like the internet, but they are the reason it stays alive. When one of them slows down, you feel it as buffering, delays, and outages. When one of them fails, entire services can disappear in minutes. Data centers quietly keep modern life running: work, banking, navigation, shopping, and communication. If you want to understand why the internet feels instant, you need to see the physical system that makes online possible: the data center.
A data center is a purpose-built building designed to keep computers running continuously. Inside, thousands of servers store websites, run applications, and respond to requests from users around the world. When you refresh a page or play a video, your device is communicating with servers that are physically sitting in a data center somewhere. These facilities are built for reliability and control, strict access rules, constant monitoring, and carefully managed environments. Data centers do not exist to be beautiful. Every design choice supports uptime. That means organized racks, dense cabling, standardized hardware, and strict procedures for replacing components without stopping services. Many companies use multiple data centers in different cities so that if one location fails, another can take over. The internet stays alive because these buildings are designed to keep computing running every second.
Servers are specialized computers designed to run non-stop, and they are the core product of a data center. A single online service can require thousands of servers working together. Some handle web requests, others run databases, and others store files like photos and videos. Storage is physical: hard drives and solid-state drives arranged in arrays, so your cloud data is actually sitting on real devices. Because hardware fails, data centers use redundancy. The same data is copied across multiple drives and often across multiple machines. When one drive dies, systems keep serving data from healthy copies while technicians replace the failed part. This is why most users never notice small failures. Inside the building, servers are tracked by inventory systems, labeled and managed like a factory floor. The internet stays stable because data centers assume failure will happen and are built to survive it.
A data center is only useful if it can exchange data with the outside world at high speed. That connection happens through fiber-optic links feeding into routers and switches inside the facility. The routers decide how traffic enters and leaves, while switches connect servers to each other with extremely low delay. Data centers often connect to multiple internet providers, so that if one provider has an outage, traffic can reroute through another. Many large facilities sit near internet exchange points where networks connect directly, reducing distance and latency. Inside the building, network design is layered: core routers, distribution switches, and top-of-rack switches that feed individual servers. Every second, monitoring systems track latency, packet loss, and congestion. When network hardware fails, redundant paths keep traffic flowing. Data centers keep the internet alive by staying connected, fast, redundant, and continuously managed.
Servers convert electricity into computation, and a large portion of that energy becomes heat. If heat is not removed, servers throttle performance or shut down to prevent damage. Data centers are designed around controlled airflow. Cold air is delivered to the front of racks, and hot air exits the back. Many facilities use hot aisle and cold aisle layouts to prevent hot air from mixing back into intake. Cooling equipment can include computer room air handlers, chilled water loops, cooling towers, and in some cases, liquid cooling directly to high-density servers. Thousands of sensors measure temperature and humidity, and systems adjust fan speeds and cooling output minute by minute. Cooling is also one of the largest operating costs, so efficiency matters. A cooling failure can force emergency shutdowns fast. Data centers keep the internet alive by controlling heat, quietly, continuously, and with backup capacity.
Power is the lifeblood of a data center. Servers, networking gear, and cooling systems all require continuous electricity. Because even a short outage can take services offline, data centers are built with layered power redundancy. Utility power enters through multiple feeds when possible, then flows into switchgear and power distribution units. Uninterruptible power supplies provide instant backup using batteries or flywheels, bridging the gap if utility power fails. If the outage continues, diesel generators start within seconds and can run for long periods with on-site fuel. Inside the data hall, racks receive power through redundant circuits so a single failure doesn't kill a server. Power systems are tested regularly under load because reliability is the entire point. Without this engineering, the internet would blink off whenever the grid had problems. Data centers keep the internet alive by making power failures survivable.
Data centers protect not only data, but also the physical machines that run critical services. Security starts outside, with fencing, controlled gates, cameras, and guards. Entry is restricted through badges, biometrics, and logged access points. Inside, sensitive areas are segmented so that only authorized staff can reach certain rooms or racks. This prevents theft, sabotage, and accidental damage. Security also includes operational discipline, strict procedures for visitors, equipment movement, and maintenance work. Many facilities use man-traps, where one door must close before another opens, reducing unauthorized entry. Fire detection systems and clean agent suppression protect equipment without damaging it like water would. Security is part of uptime. A single unauthorized action can cause downtime across millions of users. Data centers keep the internet alive by treating the building like critical infrastructure, controlled, monitored, and continuously protected.
A key reason the internet stays online is that data centers assume components will fail. Fans die, drives fail, power supplies burn out, and network ports break. Reliability engineering reduces the impact by building redundancy everywhere. Multiple power paths, multiple network links, spare cooling capacity, and clustered servers that can take over if one crashes. Services are spread across many machines, so a single hardware failure doesn't take the system down. Monitoring detects early warning signs like rising temperatures, error rates, or unusual latency. When systems detect risk, workloads can be shifted away from failing hardware before users notice. Maintenance is planned, parts are replaced proactively, firmware is updated carefully, and changes are staged to prevent widespread disruption. This is how data centers turn constant small failures into normal routine instead of disasters. Data centers keep the internet alive by making failure expected and survivable.
Many people think the cloud is separate from data centers, but the cloud is built inside them. Virtualization allows one physical server to run many isolated virtual machines, each behaving like its own computer. Cloud platforms use automation to create, move, and scale these virtual systems quickly. If demand increases, more virtual machines can be started across available servers. If a server fails, workloads can be moved to another machine in the same data center or to a different location entirely. This flexibility is why services can handle huge traffic spikes without buying a new computer for every user. Behind the scenes, orchestration software tracks capacity, assigns resources, and keeps systems balanced. Virtualization makes data centers more efficient, but it also means a software misconfiguration can affect many services at once. Data centers keep the internet alive by combining physical hardware with software that can reshape resources on demand.
Speed online is not only about bandwidth, it's also about distance and latency. The farther your request must travel, the longer it takes to return. That's why services use multiple data centers and content delivery networks to place content closer to users. A video platform may store popular clips in regional facilities so streams start instantly. Large applications route users to the nearest healthy data center based on location and load. Inside the facility, low-latency network design and fast switching reduce delay between servers. Operators track performance by watching ping times, packet loss, and jitter. When a region is overloaded or unstable, traffic can be redirected elsewhere, trading distance for reliability. This constant routing is why the internet often still works during partial outages. Data centers keep the internet alive by being distributed, so users can reach a nearby system instead of a single distant one. When a data center has problems, users feel it quickly, even if they don't know the cause. A cooling issue can force servers to throttle or shut down to protect hardware. A power fault can trigger UPS systems and generators, but if backups fail, services drop offline. Network issues can isolate the facility, making servers unreachable even if they are still running. Software mistakes can be just as dangerous. A bad configuration can take down critical routing or overload internal systems. The reason the internet usually survives is that major services are built to fail over to other data centers. Traffic shifts, backups activate, and capacity is rebalanced. But failover is never perfect. Users may experience slowdowns, login problems, or missing content while systems recover. Data centers keep the internet alive not by being flawless, but by recovering fast and distributing risk across multiple locations.
Data centers are the physical engine of the internet. Servers do the work, networks move the data, cooling removes heat, and power backups prevent downtime. You don't see these buildings in daily life, but your messages, videos, payments, and work depend on them constantly. The internet feels instant because data centers are engineered to survive failures and recover fast. Once you understand that, a bigger question appears. If the internet depends on buildings like these, what happens when the world faces outages on a much larger scale?